Hello and welcome again. So today we're going to talk about the OSI model and the layers, and we're going to do that in tied connected to the types of attacks or hacking that you can do. So this is actually a request from someone some time ago. I don't exactly remember when it was, but he asked the question, Daniel, how can we, okay, so knowing the OSI model, different kind of layers. Is there some way we can identify different kind of hacks to the layers? Because it would make it easier for me to plan an attack, for example. And I totally get it. It is more than possible to plan your attacks from the OSI model. I wouldn't necessarily say it would be the best way, but definitely a really good idea. And so let's just talk about what is the OSI model first of all. The OSI model is, as the model suggests, a way for you to do error checking on network. So basically, when you're taking education in network administration, something like that, you should be able to say like, so where is the error? The error is where. So you start with the application layer, which is the uppermost lower layer. I know it's confusing. It's the seventh layer in the top, but don't think about it too much about the numbers. Just say the top layer is gonna start there and say, so what does a user complain about? The user complain about that they cannot get to the internet. Alright, so what can be the cause for that on the application layer? That is basically what they use it for. And then you say, okay, so that is not the way, that's not the cause. You are using a browser, it is HTTP compliant and so on. I hope so. But then maybe it's a presentation layer while they cannot get into the internet. And usually, I would say, spoiler alert, it is probably not there. In most occasions, it's about being connected to the internet. So, in connection to hacking, when you talk about different kind of layers and types of hacks, the things that I usually talk about to my students is that you can use this model as a representation for how to hack. Let's talk about the very first layer. The very first layer, which is the number one, the physical layer. You got stuff like, all the signal, all the traffic, everything is on a bare bone for you. It is on a cable or in the air. There's two different ways you can transfer traffic. Either it's by cable or it is by air. When I say air, it could be different kind of medias, and you would probably say, but Daniel, isn't there more than two ways? But literally no, there's not. The first way is of course the cable way, so it's the physical medium. And the second way is of course the air way, so that's the other medium, air. So radio signals, whether you're gonna talk about mobile antenna signals, 5G, 4G, 3G, Wi-Fi, it's all just radio signals. That's basically what it is. So when you're gonna talk about that, signals in the air, you talk about sniffing. And sniffing basically is what you can do right now. You can sniff something in the air. You can sniff something on a cable. That is possible to do. It is the way to go. And I would definitely say that sniffing can be a little difficult. Now, if you have something like, let's say, a Wi-Fi adapter, or I'm gonna receive my Wi-Fi pineapple soon. So again, great. That is a part of this layer. It's called the sniffing part. So all the traffic is there for you, but you are not able to do anything with it other than you can record it, and that's about it. There's no way for you to hinder that the attacker will sniff your traffic in the air. Which is why it is very, very, very important that it is encrypted, which is happening on the presentation layer in most occasions. I'm going to get back to that. Alright, so moving up to data link layer, which is where we have the MAC address and the physical addressing. You got stuff like spoofing, MAC and ARP sniffing. Now, spoofing is a way of saying I am another host. I am host B while I'm really host A. So you're maybe taking the IP address of that particular host and using it for yourself, which is going to cause some sort of disruption in some way for the DHCP server. With, you know about that, basically it's it's a thing, you know. The MAC and the ARP sniffing, so the address resolution protocol. When you got access to the network, you can look for IP addresses and MAC addresses, which is what the ARP protocol is working with. You can use that for, of course, taking an identity as another, or you can, you know, maybe just get an idea of which kind of host is available on the internet, or the intranet, sorry. The MAC stuff is a part of the ARP, so that's why it's slashed. The third layer, it's where you can do stuff like man-in-the-middle, IP, and port sniffing. The network layer is where you have the logical addressing, the IP address. This is what the routers will look at, so you're routing on an IP address. Also path determination. There are different kind of protocols: IP, ARP, IPsec, ICMP, IGMP, and OSPF. Alright, so man-in-the-middle can be conducted by routing traffic, for example, toward you, through you, computer, and then by, you know, directing it back or to the original receiver, depending on how you want to do it. It is that way the man-in-the-middle attack can be suggested. Port sniffing is another way for you to find out, you know, whether there is an open port or something like that, because an IP address is going to be pushed towards some sort of port, which is why we're going to talk about transport layer, which is where we've got TCP, UDP, the SSL, and TLS, and these days more like TLS. But the TCP, UDP protocol, in the header of those protocols, you got the port set. So there is a designation port and also a sender port, which is filled out there. So if you can sniff those packets, you can definitely know the protocol type, you can know the port and how to communicate with it, and also the IP address. So that's definitely very important things. But these things are not hidden, you know. The TCP, UDP, and the ICMP protocol and the IP protocol does not support encryption by default. So it is clear text. Basically, all packets can be read, and if you can use that for something, well, then you can do that. Okay, moving to the fifth layer, you can do stuff like hijacking, telnet, FTP sniffing, stuff like that. This is where you have session stuff going on. So session stuff is, for example, when you have a web page and you have a session, you're logged in, so you have some sort of token that is kind of difficult to guess, but it's your token. And if someone will get their hands on that token, they can be you or impersonate themselves as you, which is why it's called the session layer. Now, this is where all the typical attacks start. You know, you learn from the OWASP series, you learn from the OSCP stuff, certifications, from the CompTIA Pentest Plus and all that good stuff. That is the last three layers, the layer 5, 6, and 7. That is what they typically and mostly talk about. So the layers beyond, layers 1, 2, 3, and 4, is more like network stuff. There isn't much that can be misused in those areas, other than you can, of course, reroute stuff and do man-in-the-middle, which is bad enough, but also ARP poisoning and stuff like that. But stuff like that, you know, the most hacks is located up in the application layer. Let's get back to the application layer in just a second. So the session layer is just where you're gonna hijack a session, you know, and you can do FTP sniffing and all different kind of things there. Moving up to presentation layer, you got stuff like SSL and TSLS and session sniffing. This is also where you have phishing, for example. And taking the very last layer, I know presentation layer was kind of... okay, maybe I should talk about encryption just for a second. You know, it's also where you have your encryption. I know it's a difficult layer to talk about in terms of hacking, because when you talk about the encryption part. You talk about you use some sort of encryption or hashing algorithm, which has been used to encrypt or hash some sort of data in a way to masquerade it, to hide it, to ensure its integrity or confidentiality or something like that, right? So moving up to the very last layer, which is called the application layer, it's going to open up for a lot of different kind of exploits. This is where you have all the different kind of software where people have been writing software. This is where people is going to write their software. It is at the application layer. So every time you have a programmer writing something like a web page or program or whatever they're going to write in some programming language, it is the application layer they work on. Which is also why people say, which kind of layer is the one where you can see all the jobs? That is the application layer, because this is where all development is. This is where all the flaws are made, where all the human flaws are made. This is the application layer. So there are so many things to talk about. Just beyond saying DNS, HTTP, SMTP, Telnet, FTP, whatever you can say that is also listed there. It's gonna be like, wow. So most exploits you find, if not all, on ExploitDB or Common Weakness Enumeration and so on, it is mostly about the application layer, because it is just where all the errors are, where people make mistakes, and people do make mistakes. All the problem is because of people made mistakes, most of them. Not judging anything or anyone, I'm just saying this is how it's made. So what I want to talk about now is how can we then ensure, now knowing this table here, how can we ensure that we do make less flaws in our development? And that is a really, really good question, and it's really, really difficult to give a good answer to it, because there is no good answer to how to make sure that humans do not make errors. It's the same question, say, how can we make sure that lions do not attack a gazelle? Whoa, you can paint the gazelle another color? I don't think it will work, actually. Maybe the first time lion will be like, her? What's that? Green gazelle? But I'm just saying that education, making sure that you hire the correct educated people, make sure you have some intro course to people that is going to create code that's going to be used. Think about it this way. So you have 1, 2, 3 developers. That is a very common number. 4, 5, 6, 7, 10 developers, common numbers of people working together writing code. So those 10 people are exposing your business in a way through port 443, HTTPS, right? And port 80, just HTTP, to the whole world. They are responsible, not the boss, not anyone else. They, the programmers. If you're a programmer, it is you I talk about. And that is the problem with security, because there's so many new young students being pushed out every year, 2 times a year, as developers. People, they want to do less education and want to do more work, gonna study less, more YouTube certified stuff, you know what I mean? Just go out and take a job, and then get it done. And it is not like doing manual work, like putting boxes on the top of each other. While it can look like that in some occasions, it is just not like that in reality. So giving those kind of people with that kind of attitude a job with the possibility to expose port 443 and port 80 to the whole world, that's incredibly stupid. And I kind of want to stand with that, because I really don't get it. Why can't we do it? So I'm going to end the video now and say that I really hope that with my reflections as a teacher for bachelor students, teacher for academic degree students, teacher for my own security elective, and teacher for people already having a job. I don't know what you call that, but after education while you have a job, that is also something I do. I see this a lot. It's what they tell me. It is what I read in statistics. So I'm not taking this as a biased thing. I'm just basically trying to be a bit more hard and direct about, we really need to focus a bit more on security, guys, especially on the application layer. So I really hope you learned something today, and I'm going to see you again online, and have a really nice day.